Hello, maths fans. Looking at interior and exterior angles in polygons. We're going to go through some questions here today, and these questions are from My iMaths. So if you are doing either of these My iMaths tasks down the bottom here, this isn't going to show you everything, but it'll give you some good ideas and a bit of help on these two topics. But also if you just want to have a look at interior and exterior angles. So, we need some formulas for irregular and regular polygons. There are sort of three real key formulas that we need to remember. One is that the sum of the interior angles is 180 multiplied by the number of sides minus 2. So, for example, if we have an 8-sided shape, we would be doing 180 times by 8 minus 2, which is 6. 180 times 6 would be the calculation to find the total of all the interior angles in an octagon in there. Next useful fact is that the interior and the exterior angles, exterior on the outside, interior on the inside, they form a straight line. Always form a straight line, and therefore they add up to 180 degrees. So if I want to calculate the interior, and I've got the exterior, I do 180 minus the exterior. And my last formula is that in a regular polygon, this is only true of regular polygons, one exterior angle is 360 degrees divided by n. And in regular and irregular polygons, we always have that all of the exterior angles will add up to 360. So this calculation for working out one exterior angle only works for regular, but in all shapes, the exterior angles round the outside always add up to 360 degrees. Those are our formulas we're going to use. Let's put them into practice. Here's the first question. So we've got a triangle here, and I don't know this angle yet, but if I do find it out, I'll be able to find this one. So first things first, triangle adds up to 180. So to work out this angle, I've got to do 180 minus these two. So 180 minus 49 plus 49 is going to be 180 minus 98, which is 82. So that angle there is 82 degrees. Put a little degree there. And then what I know is that I have a straight line here. So those two angles must add up to 180. And in fact, we end up back where we started with the 98. So x equals 98 degrees. Okay, so we found angles in a triangle add up to 180. Then we look for that straight line, and that adds up to 180 as well. 180, very useful in angles. Next one then. Okay, here we have all exterior angles here. Now there's a couple of ways of doing this one. I could work out the angles on the inside, here and here. That would allow me to work out this one, and then I could take away from 180. But I'm not going to do that, because I can also take a bit of a shortcut. I recognise that these are three exterior angles, and if you think about what these will all add up to, if I go all the way around this shape, turning through these angles, I'm turning through 360 degrees. And I can demonstrate that. If I bring these all together, you'll see that they add up to 360 degrees. Those three angles there are making a perfect circle, because they are three exterior angles. So they must add up to 360 degrees. So if I do 360 minus 154 and 76, I'm going to get 154 plus 76 is 230. So 360 minus 230, I think, is 130. And that is what x is, 130 degrees, because they all add up to 360. So look out for those 3 exterior angles there, they add up to 360. Okay, let's have a look at another one. Right, here we have a special triangle. These lines mean that these sides are the same length. And so this triangle is an isosceles triangle. And that means that this angle is equal to this angle. So they are both the same. We'll label that one X as well. First thing I can do with this one is work out that angle. Straight line, so 180 minus 116. 180 minus 116 equals 64. And then I look at this triangle, and the 3 angles add up to 180. So the 2 x's are we're going to have 2x plus 64 equals 180. So now if I do 180 minus 64, I actually get back to the 116. So 2x equals 116. And then if I divide by 2, I get x equals 58. And that means that these are both 58. 58 there and 58 there. Okay, let's have a look at another one. Right, we're now going to work out the exterior and interior angles of a regular polygon with 18 sides, an 18-sided shape. I don't know what the technical name for that is, but we're going to work out the exterior and interior angles. Well, the exterior is going to be 360 divided by the number of sides. Remember that formula from the start? So 360 divided by 18, that is 20 degrees. So one exterior angle is going to be 20 degrees. So if I imagine that's 20 degrees, that's my exterior. To work out the interior, we take away from 180, 180 minus 20, and that is 160 degrees. So simple as that. Finding the exterior and interior angles of regular polygons, 360 divided by the number of sides, take away from 180. That's it. Easy stuff. Let's look at finding the sum of the interior angles of a polygon with 26 sides. Well, this is where I use the formula for the sum of the interior angles. So all of the interior angles add up to this. And that is 180 multiplied by 26 minus 2. And that is going to be 180 times 24. And 180 times 24, I think, is 4,320. I didn't do that in my head, I wrote it down earlier. And that is the sum of the interior angles of a 26-sided shape. Second part here, a regular polygon has 22 sides. Find the size of each interior angle. So this one at the top here was the sum of the total, which is going to be a huge number. Each interior angle, that's going to be a much smaller number. It's the individual angles we're looking for. So what I can do is I can work out the sum of the interior angles using that formula, n minus 2 times 180. In this case, that's going to be 180 times 20, because 22 minus 2. And so the sum of the interior angles here is 3,600. And to find one interior angle, I divide that by the number of sides. So if there are 22 sides, 3,600 divided by 22, and that equals 163.6. And that is what each individual angle is, 163.6 degrees. And that's a way to do it. With this one, because it's a regular polygon, I could actually ignore this formula and use the exterior angles formula. I could do 360 divided by 22, which would give me, I think, 16.4 or something like that. That would be one exterior angle, and then I could do 180 minus 16.4, and that would give me 163.6. So there's a couple of different ways of doing it. They both lead to the same answer. I personally prefer using this one, but it's nice to be aware of both. All right. On the iMaths then, it goes on to this rather scary looking question. But if we break this down, it is not so bad, really. First of all, find all of the interior angles that we can. So this one, this one, this one. We're dealing with interior angles here. So I can find these all by these two add up to 360. These two, the 140 and this one, add up to 360. These two add up to 180. So if I put those numbers in, I get 220, 137 and 146. And now I need to know what all of these angles add up to. Well, this is a 1, 2, 3, 4, 5, 6, 7, 8-sided shape. It's an octagon, an irregular octagon. So it's got 8 sides, and that means that the sum of the interior angles is going to be 180 multiplied by 6, because we do 8 sides, take away 2. And there is my sum of the interior angles. All of these interior angles add up to 1080 degrees. So now I do 1080, take away this, 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 and I'll be left with x. And when I do that, I end up with 123 degrees. Okay, final question then. Again, iMaths gives you something that looks a bit intimidating, but we have a line of symmetry here. So this helps us out loads. If this is symmetrical, it means that this angle is the same as this one. And we can work out this interior angle as 360 minus 88. And so this would be 272 degrees. And then again, with symmetry, that one would be 272 degrees. Now let's count the number of sides. Well, there is 1, 2, 3, 4, 5, 6 sides. So it's a hexagon, an irregular hexagon. And so all of the sides on there are going to be adding up to 180 multiplied by 6 minus 2. So that's 180 times 4, which is 720 degrees. So all of these add up to 720 degrees. And so I do 720 minus all of those other angles, and I end up with x equals 77. All right, there's some questions. Hope you've followed those. I suggest having a go at my iMaths now.